Hi, my name's Josie,
And I'm Emily.
and we're doing our multivariable project about the connection between multivariable calculus and microeconomics. And we decided to do this project because both of us are taking Intro to Microeconomics this semester alongside multivariable, and we noticed that there were some connections between the two. And so we wanted to further explore that.
Yeah, and so our approach is kind of taking like a real world application of partial derivatives because we noticed that the functions for production and for profit can really easily be distilled into multivariable functions. And so using partial derivatives, you can kind of find out how individual things such as price and quantity and labor will affect the overall outcome of production and profit.
Yeah, and so I'll go through an example about production, and Emily will go through an example about profit. And so for production is based on the quantity produced, and the quantity produced is a function of capital and labor. And so capital is like the material goods that are being inputted, and then the labor is the people who are being inputted. And so as you can see from this is a multivariable function, and so in order to further analyze it, we can take partial derivatives to see how the change in labor is affecting the change in output, and the change in capital is affecting the change in output separately. And so there's this, the marginal product of labor, which is the partial derivative in terms of labor, is something that we learned about in class, which is the additional output that can be produced by using one additional unit of labor. And so you take the partial derivative and you get the marginal product of labor. And so we can see here, this is a graph of output, and this is a graph of the marginal product of labor. And so through this we can see some interesting things. The first one is that at this point when the quantity, the slope is 0, this is when the marginal product is 0, which makes sense. And this is also when production is maximized, which makes sense because when you have more labor and you aren't producing any more, then it makes sense that that would be when production is maximized. And then on this here, we can also see that when the marginal product of labor, when that slope is 0, which would be the second partial derivative, that is when diminishing returns begins to set in.
Yeah, and so on the profit side, we can see how profit actually ends up being a multivariable function with price and quantity, because overall, yes, it's profit equals total revenue minus total cost, but total revenue and total cost are functions of price and quantity in and of themselves. And so if we plug in what we have here for total revenue, which is just P times Q, and total cost, which is 8Q plus 100, then we get this function overall for profit. And so if we take the partial derivative of profit with respect to quantity, then we can see how a change in quantity, just change in quantity, affects profit. And so this will give us P minus 8. And so this makes sense because the reason why total cost is 8Q is because it's taking you $8 to produce one unit of output. And price is how much you get for that 1 unit of output whenever you sell it. So if you sell 1 unit of output, you get P in revenue, but then you lose $8 because you had to spend those $8 to create that one more unit. So yeah, we hope this helped, and thank you.